And then the literature review. Okay, this is just a summarized screening process for the literature review. It shows the papers that I've screened, the ones, it shows the number of the ones that were not relevant, and then the ones that I used, papers were reviewed for this study were 155. So, yes, this is how I did it. And then, as I continue with the literature review, so this one, it shows the methods that others used to develop the framework. So I'm not gonna go through it one by one. So, yes, so as the literature review goes, because to answer objective number 2, I said I will identify factors which affect rail manufacturing SMMEs when they go into a global market. So this pie charts, they show how SMMEs are doing in the market. So it shows the green is the blue is the agriculture, and then the mining is the red one, and manufacturing. So it shows that 91% of small size enterprises, they are in manufacturing. And then in medium sizes, it shows that it's 85%, which is the higher percent amongst them all. So large size firms, it shows it nearly balanced the chart, even though it's not balanced. And then as I continue with my literature, you can see that really small businesses, when it comes to exporting their product, the graph is so low, it's so small, close to 1.1 is so small. So for medium sizes, it's 5.6, which is still very low. So for the large ones, they're the ones who are flourishing. So that's why this framework is needed to help these small, medium ones to also grow in this global production and networks. So the methodology that I've used for this study is the qualitative research was conducted using the grounded theory strategy. So apart from the literature that I have used, I also used the workshop that I have attended to get some of the factors which affect these SMMEs. And then these two were conducted as a systematic way to gather scientific facts to validate this finding from literature. So my framework, I will evaluate it by using the simulation plan A, which I haven't done, is still gonna be done. So as I continue with my methodology, it shows that I have applied this descriptive theory building procedure, which shows the observation, the categorization, and the association, where through the literature I gathered the information which shows the factors which affect the growth of SMMEs to operate in a global production network. So I used this theory building procedure to identify those factors. So when I was putting the concept aside and then putting them into categorization and check their association. This shows the framework development method that I have used step by step. It shows the events that I've attended to gather data, and then even the literature. So it goes down step by step like that until the framework is validated. So this result, I don't know if they're clear, they look so small. But then this is, in a nutshell, this is the concept that are gathered from the literature, and then from the workshop that I've attended. So I've categorized them, and then I've put them in order so that I can be able to develop my framework. So this is the continuation. So this is the answer for my research question, or rather my objective number 2 for documenting factors which influence globalization in manufacturing. So they were obtained through the review of literature and through the workshop which I've attended. So I've categorized them into 5. The technology environment, it includes those, the legal and regulatory, political environment, socio-cultural environment, and economic environment, in order for SMMEs to go into global market. So these are the ones that helps with the development of the framework that I want to do. So this is the predicted framework. This is how it should look like when it is completed. So it shows that the more there is a lack of market access, the lack of market access, it increases the high cost of doing business, which reduced by profitability finance assistance. So the skill shortages, it increases, backslide, okay. The skill shortages, it increases the high cost, again, of doing business, because if the managers or the employees, they lack skills, it means that there will be too much scraps and other things, or they don't produce a good quality which can help the SMME to grow into a global production network. So, yeah, in a nutshell, this is how the framework will look like when it's complete. And then it will help these SMMEs, because the value chain, when the value chain suffers when one company closes. So if these SMMEs can grow so that they can be able to compete into a global market, it will increase the employment in our country. It will assist again in the alleviation of poverty in the country, because there will be more opportunities, or there will be more chances for others to grow others and to train others in this regard. So the results outcome, this framework will help SMMEs to grow and operate into global production network. It will also provide understanding of the entrepreneurial decisions to go global, which involves the need to study the thinking elements of the entrepreneurial decision-making process and factors to take into consideration when going into a global market. So in conclusion, so SMMEs are still faced with more challenges, which weighs the chances of survival in this competitive world. So if we are honest, we are able to see that SMMEs, they're really faced with a lot of challenges when it comes to finances, when it comes to adopting new technologies, when it comes to a lot of things that they need to be done in a manufacturing company. So they really experience more challenges than larger firms. So through research and innovation within the manufacturing enterprises, this can help the growth and more competitiveness within the SMMEs environment. So this global production networks is more critical form of organization. So these SMMEs, they really need it so that they can expand their market, and then so that they may not be behind with new technologies, so that they can be able to adapt and stay in business and stay relevant. So this framework will assist to to identify influence factors which affect decision-making in rail manufacturing SMMEs when forming a global production strategy and managing the production networks. As I'm about to finish, so this is the significance of the study. The significance of this study needs to highlight the opportunity to establish a framework for the local, regional, and broader third world economies, given the current challenges in the part of the world. So these are my references. And then I would like to acknowledge TUT, the Gibela Rail Transport Consortium, and the NRF. I thank you.
Thank you very much. I understand that this was a colloquium presentation, so I'll call the research chair to facilitate this process. And the next presentation as well is a colloquium presentation, so I'll be off duty until it's done.
Hello. Thank you very much. I think the colleagues from Gibela, in terms of the work they are doing with SMMEs, one of the most important things is to see that SMME growing from, you know, a backyard player, getting some small industrial place, and then one day, you know, you waking up and getting a call that that SMME has got a tender from Europe or from America or from Asia. And so this work is work that is really trying to say, how do we look at this and how do we facilitate this process so that these guys don't just depend on supplying Gibela, but they realize that, you know what, the manufacturing industry globally is the space that they can play in as well, though they've been developed at Gibela. So I would like to give you the first opportunity, you know, to ask some questions with respect to what has been done and the practicalities of it. Does it really, is it really taking the art of helping these SMEs be global production networks, or it's just not understanding the dynamics really? So I'm not sure who's gonna go first. We definitely need some industry input here.
I had my own questions based on the presentation, but I'll start with entertaining what Prof is saying. So based on my experience, particularly on the railway industry, our SMEs are struggling, even locally. So it will be interesting to see how your framework will be able to assist them to go globally, but they need to be assisted first, actually, even locally. I mean, it's not easy working with a big giant like Gibela and you're an SME, because there's a lot of things that we work with, because Gibela, it's quite a big organization and SMEs are not aligned to that. I'll give an example. Maybe Gibela account will be flexible, that we pay our suppliers maybe within 60 days. You find that SMEs are not surviving that long. They need the money as soon as possible, because, and most of them actually, they are in jobbing environment, meaning that they're depending on that person who will knock on the door and say, make this product for me, and that person will never come back again in the next year or so. So when they're working with a project like Gibela, they need something that is more serial, where they'll be able to maintain the cash flow. So it is an interesting study, but I think we need to first make sure that locally they are stable, so that when they tap into the global market, they will be able to support that. Because you must remember that when you're looking at manufacturing, so if I'm an SME, I'm manufacturing a product. If I send that product to Egypt or wherever, and that product has problems, I must be able to have a team or I must be in a position to be able to go to Egypt and support my customer in terms of doing reworks or doing warranty maintenance. So those are the things that we need to look at, but it is possible that these people can go globally. I mean, if they can do work for Gibela or for automotive, for instance, because you know, with automotive, a lot of the products go overseas. So if they're able to support the automotive market where their products are seen overseas, it means that they can survive there. But it's just processes locally that needs to be in place so that when they go globally, they do not suffer. Thank you.
Do you have your own questions?
Yes, I do have questions.
Maybe she can list them in the meantime while
Okay. On your slide where you were talking about the results for objective number 2, I thought maybe you could quantify so that we can see how your research and what you have seen in literature links up. Because you had a slide previously which was showing the graphs, which was showing the different problems that the SMEs are experiencing. You had percentages on that. So now this is your findings. I was interested to see if this links up to what you have seen in literature in terms of the problems. Are the problems still the same in terms of quantity, or are they getting better? Are they getting worse? So that would have been important to show. And also maybe to take you back to your framework. I'm not sure how it's working. I see it's sort of like a loop, but I'm not sure how do you apply it so that we are able to assist the SME to go into the global network. Thank you.
Thank you, Maringa. Very valid points. You can see you're speaking from experience. Are there any other hands from the industry before we go to the other colleagues? Thank you very much. Dr. Dan?
Thank you so much, Ms. Junior, for that presentation. Please, can we go to your framework, the developed framework? Okay, so please, it will be fine if you can explain to us how we can achieve predictive capability with this framework, because I'm seeing that the title is a predicted framework. Do you mean that this is the framework you are predicting, or the framework has predictive capability? Please, we need to be very sure. So that's my first question. Then the second question is that please make sure that your conclusion aligns with the objective of the study as much as possible. Then it will have been fine if we can see more of the qualitative approach that you use, you know, in this study. Maybe you have used the meta-analysis, content, and synthesis to come up with some of those findings and recommendations. It will be fine. So those are my comments. Thank you so much.
Thank you very much, Dr. Dan. I see there are more hands. In that order, Sekano and Kosana, then we allow Mahatlakala to please respond. I take it that you won't need to project anything, right, when you respond. So the next presenter can be setting up so that we are efficient with our time.
Okay. Mine is a comment. I think this still on this predicted framework. I think you should consider taking this framework and putting it into a system dynamics model, because that's what I see. I think it will assist the process. Thank you.
That's a straightforward comment. Skosana?
Okay, thank you. In the previous session, Martin spoke about problems and opportunities, and he was trying to make a difference between the problems and opportunities. So right now, that's the same question I have, like for you, Junior, because you spoke of a lot of problems that SMMEs are going through. Are you aiming to solve all those problems, or you just want SMMEs to be aware of those problems and not necessarily solve the problems? Because then if you're going to solve all the problems, you might take forever.
Junior, you can respond.
Okay, I'll start with you, Mr. Skosana. No, I'm not intending on solving any problem that SMMEs they are facing. So this research is making aware of these SMMEs when they go into global market. There are certain challenges that are there. So they need to know how to deal with them. But then they are not there for me to solve them. So I'm just outlining them that, okay, this is kind of challenges that are there in SMMEs. Thank you. Okay, Mr. Sikano, it was a comment. So, Dr. Danyan, okay, as I said, this is a predicted framework because I still have to evaluate my framework, so it's not the final one. So that is why I said it's still the predicted one. So yes, the proposed one in a way. Sure, that's the right way for it. Thank you.
And then Maringa.
Oh, Ms. Maringa. Okay, your question is, you were saying that SMMEs are still struggling locally, and then how to help them to grow globally. So I think in SMMEs, there are still a lot. That's why I said the challenges that SMMEs are facing, they really weighs their chances of growing in this competitive market. So that is why I come with this framework that we can't solve all the problems at once. So, but then the ones that we will be focusing on, they can really assist them to expand in a global market. I think the other thing is the quality that they produce is very much important, because if a potential buyer sees this kind of quality, they really stand a very good opportunity to grow abroad. There's another one. Okay, you said these problems are getting better. So, okay, actually this work that I'm doing, it doesn't show that they are getting better, because you see on the graphs, it's from 2007 and then it's up to 2019. So the problems are getting more and more, like in these SMMEs. The more they face challenges, because you see technologies, they are changing. You find that you are still doing a door which when you open it, you have to wind it, but then now you just have to press and then the window opens. So they are growing. Actually, SMMEs, they are really behind. So we need research and development in our local SMMEs so that they may keep on track with what is happening in the manufacturing world. So, yeah, I don't know if I left the other questions.
Yes, no, thank you very much, Matlakala. You seem to be becoming an expert in this matter. Maybe you must start as an SMME, that is going to help Gibela, help its SMMEs, take their enterprises globally. Because it's very good for the economy, If you look at economies like Germany, you discover that those economies, they are standing because of the SMMEs that are supplying globally, So yes, there's a battle there, but maybe from an incentive perspective, it would be nice to say, maybe the DTIC should consider these types of incentives when people have opportunities to play in the global production networks. But we do have, in the Mesita project, a company called Sling. I'm not sure if the team that was working on Mesita, Dr. Dan, you are part of that team, ne? Where Sling was supplying aeroplanes to Where were they supplying aeroplanes to, Dr. Dan? You don't remember? You're forgetting too quickly. Bibili, you remember? I think there was a UK somewhere, if I'm not mistaken, but it's a small company, you know. So those questions that you are raising, Maringa, that if these guys are supplying to international places, then if there are warranty issues, then they must be sending people. I'm not sure how they are dealing with them, but maybe Matlakala, when she goes to redo her homework and clean up the document and finalize so that we have the final model, because we can't conclude the study with the predicted model or the proposed model. We need to have the final model, which we can then, you know, take to the DTIC and talk to the colleagues at the DTIC. So at this juncture, we're going to hand over to Teboho Modibedi. Teboho is coming from us from Kokta. So he's a very important member here, especially in terms of energy efficiency, because it means that this solution can be quickly in the municipalities, you know. So yes, he's delivering his colloquium, but we need to also, you know, have discussions with him offline in terms of, you know, how do we access the municipalities, because the solution of energy efficiency is also good for the municipalities. Yes, I think the colleagues from Gibela also did say that SMMEs mustn't only think that Gibela is the only consumer of the developments. The municipalities are a big portion of the budget of the state. And if we have these solutions going there, maybe, you know, so there's a nice conversation, we can start there. It's good that Prof. Munda from the electrical side is here as well, and we can make sure that everything is watertight. And we can be stronger. But I don't want to waste your time. As was said earlier on, if you finish earlier, but do the job properly. If you finish earlier, they will give you scores, those members there, because you are saving us on time. And you can be very nicely decorated at the end of these sessions. Thank you.
Thank you, Prof. Good day, everyone. My name is Teboho Modibedi. I'm busy with my master's. It's a mini dissertation. So I'm at the colloquium stage. So the topic is development of performance measurement for electrical network in Rustenburg local municipality. So my background is I'm an electrical engineer, as you can see also with my topic. My supervisors are Prof. Mpofu and Dr. Adenuga. Also, my presentation outline, I'll speak to the background, problem statement with the research questions and objectives, the literature review, the methodology, the results, and conclude with the conclusions and recommendations. So with the background, what guided my topic was the interruptions that we've experienced or that we've been experiencing in the local municipalities, mostly the ones that are in the rurals, semi-rurals. So that's where you'll have most interruptions, and they don't have systems that monitors, that can give the municipalities an indication where they should focus on improving their network, be it for maintenance, and even enhancing their revenue collection. So that's what guided this study, and it's outlined on my background. So the main thing that I targeted that we can use to measure the performance of the network is the SAIDI and SAIFI. It's indices that are used, is mainly used in ESCOM, which is a reliability measure that they use, and you can set targets that you can measure against. So you'll set those targets maybe for your SAIDI, you'll choose a target of 2 per annum, or for your SAIFI, which is also maybe around 1 or 0.5. But I will speak more on the indices, on the methodology. Okay, on the problem statement and the questions and objective, it's a bit wordy, but I had to put it like this. So the problem statement, I think I've just touched on it. It was formed from the interruptions that were experienced. So it's one thing that we're trying to mitigate, or at least minimize, in terms of how the municipalities respond to faults, the duration thereof, and also the frequency, trying to reduce basically those two aspects. And at the end of the day, also, the study will also inform the maintenance interventions that are required there. So the research questions that the research study aims to answer is how reliable is the network, how frequent the interruptions are happening, and also how is the network currently being maintained, the cost implications. And the objective of the study is to capture the actual interruptions that are happening throughout the entire network, assess the network as well, and also develop a tool that the municipality can use, capture these interruptions, input, and also see how the network is performing. And also at the end, obviously, draw definitive conclusions that can be implemented. So the literature review, initially, I started by elaborating on the network that we'll be focusing on. So with these indices, I made it will focus on the MV network of the municipality. That's where it's efficient on, because with this MV network, it's where customers are addressed. That's how you feed your customers, and also you have regulating bodies like your NERSA, Energy Regulator of South Africa, that measures municipality their performances on these indices, and they are not measuring them. So also I elaborated on the different arrangements that can be looked into by these municipalities. So for example, you have your radial, you have your ring feeders. So with this arrangement, if it's a radial, it means all customers are in one line, and if a fault happens, everyone is out. But if you have like a loop, for instance, a ring, so some will be out, you can attend to the ones that are not affected. So there are different arrangements that can be looked into, and I elaborated in depth on those. And also I reviewed the different technologies that they can look into that can improve the reliability. So obviously that comes with costs, but with this tool, this spreadsheet tool that I also developed, it's easy for them to just input the interruptions and they can assess their network. So I also looked at different case studies. So there was two that I looked in depth on, which is ESCOM and also one in Fiji Islands. So on those, I reviewed how they implemented solutions to their network interruptions. So also, mostly it was the maintenance interventions that they used, and also the technologies that they used to improve. So that the slide just further shows all the aspects that I looked into for literature review, so also with the different authors. So as I just mentioned, I reviewed the performance of the different networks that have been looked into in terms of these indices, and also the different technologies that are available, finalizing with the cost implications. So the research methodology, this just shows a bit in depth the calculations that we used in terms of the SAIDI-SAIFI to measure the actual interruptions. So just briefly, SAIDI is the System Average Interruption Duration Index. So it basically measures the interruption from time of the fault to when it was restored. So you have to measure your performance based on that and try to reduce that as much as possible. So obviously with this spreadsheet tool that I'll show you a bit later on, that I developed, it'll show exactly the duration thereof. And also SAIFI is just now the frequency index. So how often these faults are occurring and how we can minimize them. So this the diagram just shows, as I just mentioned, from the time the fault occurs to when it was restored. So we're trying to minimize this as much as possible. And this will significantly improve on the performance of the network, or how the customers are actually fed from the network, how reliable the network is. So the stages are the methodological stages that I'm going to go through. That I went through were the research questions, obviously, trying to address the research questions, but also collecting the actual data, the raw data. It was a tedious process. The data was collected over a period of 12 months. So also with that, I also had to validate, clean this data to make sure that is the MV network data that I need to actually input into the to the tool. And with that, I categorize it into the substations, the feeders, the duration of the fault, how early it was cleared, and yes, with that, I was able to calculate the SAID and SAIFI. And the last one will be analyzing this actual data to show what is leading to these faults and how we can mitigate them. Coming to the results, the tool, with all the inputs, inputting the different faults in the tool, it will now calculate the SAID and SAIFI performance. So as you can check with this one, the target was 2. The municipality aims to achieve at least 2, which is also a NERSA regulation as well. So from the graph, it's seen that the performance is out. So also, I was able to identify the different feeder performances. And from this, we can see which feeder needs urgent maintenance and improvement. And further on, with the tool, I was also able to identify different performances, a lot of factors in terms of frequency of interruptions and also equipment failure rate. And as you can see, I can identify that transformers are the ones that are more troublesome, and on that, maintenance can be specific to address and minimize faults that are occurring a lot on transformers. So there are also root causes that I was able to evaluate. Cable theft came out tops, which is also on the feeder performance. On the Mokwasi feeder, as you can see, most of those faults occurring are from the cable faults. And also, if I can just, before concluding, okay. So this is the spreadsheet that I developed. So this is a dashboard that will show the actual performance, but this is the inputs that we put in terms of the interruptions that are occurring. So as I said, everything is categorized. The substation name, the feeder name, when the incident occurred, the root cause of the fault, base, the customer that is feeded from, and all these columns guide the calculation of the SAID and the SAIFI. So this is the tool that I used to collect the data, the raw data, and therefore linked it to the dashboard to show the performance of the network. If I can just go back to the presentation. Yes, so just to conclude, so the spreadsheet-based network performance that I developed, I was able to pilot it in the municipality, and that's how I was able to get all these results. So obviously I was assisted by technicians to collect the data and input all this raw data into the tool to be able to assess the network using these indices. So obviously the recommendations is if this tool is used, and well, it is currently used, they've adopted it, which is something that I'm proud of. So it will assist them in identifying where the network is not performing nicely, identifying the different feeders that they must focus on, and also from the literature review, I elaborated a lot on the different technologies that they can use. So there are easy ones that they can implement to because okay, municipalities struggle with funds. So you'll have these systems that are ideal that they can implement, but funds are the issue. Hence, I developed this tool that is easy, and they can easily input the data and just see on that dashboard where they should focus. So the system that I'm talking about that are digital, that are smart, is like your SCADA. So you find that mostly in your metros. But in this in this small semi-rural municipalities is an issue. So with further research, I'm intending maybe for my doctoral studies to implement such a system in the municipal, maybe call center, which can be automated and digitalized from then on to speedily address these issues. Thank you very much.
Thank you very much, Teboho. Looks like there's hope for our municipalities in the midst of darkness. So are there any questions at this juncture in terms of the work that Teboho has done? I see Dr. Dan. Unfortunately, I think Mulalo has got another meeting, but it would have been a very interesting piece of work for her. But let's allow Dr. Dan to please ask his question. Dr. Dan, please proceed.
Thank you so much for that well-articulated presentation. Thank you so much. So please, can you go to your background? That's the first slide shown there. So I just want to make a quick correction here that the background to the study relates to how the problem started and the efforts that have been geared towards solving that problem. So if you look at this slide now, you see that it speaks to another thing entirely, so you can make that correction. Then you can also go to your problem statement. You know, this work has to do with performance measurement. So there is a need to include the relevant statistics of those interruptions that you have talked about under the problem statement, if possible with the with the necessary citations. Then another thing that I noticed in the work is that the research methodology is not clearly articulated, though I understand the fact that you are coming from electrical background, but you find yourself in industrial engineering, and you know, there is an adage that when you are in Rome, you behave like a Roman. So in line with the, what's it called now, with how research is carried out in industrial engineering, you need to be very clear on the research methodology that you are adopting. For instance, the data you have used, where is the data collected from? Are you using a case study or a qualitative or quantitative approach? You know, all those things need to be properly captured. For instance, here you just say quantitative. Data of network interaction was captured from where? You need to know. Then, in relation to this also, you need to also employ some industrial engineering techniques or tools so that everything will not look only electrical. So there are so many industrial engineering tools and techniques that fit into this work that you can apply so that your work can be a balance of your background and the current department that you are pursuing a degree in. Thank you so much.
Thank you very much, Dr. Dan. So obviously, from an engineering perspective, Teboho is an electrical engineer. There's no secret about that. But of course, Dr. Dan, you're perfectly in order. Now that is more focusing on engineering management in this qualification, that in engineering managementness must appear and must be apparent. So Teboho, I think those are elements that you can, speak to in the dissertation as it is being finalized. It doesn't need a response. It needs just actioning in terms of the dissertation. Are there any other questions, comments, value adds? There's no possibility, yes, Kosan, of developing virtual reality content that can assist with these systems.
Thank you.
So the other thing that I want to maybe ask you, Teboho, is that have we, from what you are saying, is there an opportunity for us to talk to the IP department now that there's all these things about protection and all that? in terms of what you've done. Now that it's also being utilized as a solution, I take it that the municipalities are being saved millions of rands, and we are struggling here with masters and doctorate scholarships, you know. So these solutions that are being developed in the corridors of university, we need to find a way of, you know, paying back the money, if you understand what I mean. Or it could be actually maybe conceptualizing a program that can then support whatever your guys' unit is doing from an engineering management perspective. So I think those are conversations that Mr. Nanselele here will be happy to have, so that we can find those connections and take the discussions forward. But thank you so much for all your hard work. Please apply yourself to these suggestions that have been made. The DCPS will sit. When it sits, it will then make a call in terms of the presentation today. But right now, I'm going to hand back to the program director and still emphasize that our adjudicators are scoring handsomely for the people who are saving on time. So be reminded of the importance of that. I would have made a recommendation, but I don't want to influence them.
Thank you very much, and congratulations again to the two presenters that have almost reached the end of the road. And now I have two presenters here that you need to be wary of. They have just entered into the academic space. They are undergrad. All right. So I'm just fixing that. So they're going to be showing off their posters that they have. And I'm emphasizing that they're undergraduate. I'm biased to that level. They are mine. So, so I will need you to handle them with care as you engage them. The first presenter is Busiso Mahlangu. And then he'll be followed by Tato Tebe. An applause of encouragement.
All right. Good afternoon, ladies and gentlemen. As introduced, my name is Busiso Mahlangu, and I'm a third-year BEng Industrial Engineering student. First and foremost, I would like to thank the opportunity that has been given to undergrads as well, that we may be in a position where we get the similar exposure to the postgraduates. What I am presenting on is a poster that is centralized or more focused on the end user, which are the customers. What we've came to see is that most of the presentations were on manufacturing, which is the core of what Gibela deals with, but the trains which are manufactured for PRASA, and the end user is the people that actually make use of this trades. So as the introduction states that most commuters take the trains get left behind on a day-to-day basis as they proceed to their workplaces. So what we've realized is that a lot of trains leave the train station with not as much commuters as they would have aimed to, due to the commuters being late. But what we aim to establish with this concept is that if the commuters can have a commuter train tracking unit, an app, where they can actually look at the they can actually track the train before they go to the train station. So most of the time, commuters don't go to the train station to take the trains because they think that the train has already left the station, whereas the train has not even came to the station due to maybe breakdowns or due to maybe cable thefts at most stations. So the aim of the concept is to assist train manufacturing companies in maximizing profits through ensuring that each train departs from the station with at least 80% full commuter capacity. So the question might now be that what does this have to do with Gibela as it is a manufacturing company? The aim of it is to strengthen, the relationship between PRASA and Gibela by coming up with an innovative concept that might bring back the commuters that they might have lost due to the downtime or due to the off time or the transition time from those yellow trains to these blue trains. A lot of people opted for taxis in Cassis, where a lot of people that use trains actually live, and we can use this concept, or this concept can be used to reassure them that the trains are back and the trains will deliver according to what they aim to do. And the bigger part of it is that if the commuters are not happy, then the commuters are not going to take the trains. And this might now impact negatively Gibela in the sense that demand of manufacturing the trains might now decline. So if we implement, I believe if we implement this, it's more of a customer feedback from the commuters to PRASA, which indirectly affects Gibela. So when we move on to the methodology, so we will conduct adequate research and planning on that, and then we will gather all inputs that will go into the unit. As I was talking to Ms. Morado, she told me that the trains do have tracking units already, so which is a positive thing, because now the only thing that we have to do is to create an app that they can access. So even when they are at home, before they leave, they can actually track their scheduled train at 7 o'clock. If they have to take 7 o'clock train, they can actually track it to check if it will be at the station by 7 o'clock or not. So that is just short and sweet for my part. Thank you very much.
Short and sweet, even if he has to say so himself. Any quick comments and questions, basically for Spoo? Okay, I'll start with Olani and then Luvuyo in that order.
My question is, how are you going to make money from this?
Do you want money?
Okay, so I think one question from my side is, because you speak of an app and you speak of ridership, is the app going to make people take the train? Or I'm not drawing the line between the app being an enabler and the app being a marketing tool. And then question number 2 is that for someone who's taken the Gautrain quite a few years, it has a similar system to what you are proposing, where you can log on to the app, see if there are delays, very strict timetable. Have you done a benchmarking exercise with them and said, okay, since you guys have this system, has it increased ridership? Because, I think let me just ask and not make any comments. Thank you.
Thank you. I think I saw the third. All right. That was all the hands, Boo.
All right, thank you. I strongly believe that the rise in commuter or commuter participation going back to the trains, it will increase profits for PRASA, which will increase the demand for Gibela. Let's say, for example, now the train takes, let's say, 500 commuters now, just hypothetically. And if that is met, for those trains is met, that will make Gibela to manufacture more trains. So the higher the commuter attendance, then the higher the demand for Gibela. My money. Or me, it's partnership. I think through partnership, where I launch the concept and I develop more research of it, then we can reach some sort of partnership with Gibela. Are you good? Thank you, sir. Second question, it's on how train, and yeah, I did, through research, I did check the apps. So I downloaded the app for How Train, and then I could see that it was actually running at a much efficient rate as opposed to I actually downloaded the Metro Rail one. So that one is slow, it does not even launch from time to time, as opposed to the one of How Train. So yes, it's an established concept in a way, but I believe those are different target markets. The people that go on How Train, people that take Metro Rail or the PRASA trains, it's two different target markets. Does that answer your question, sir?
Thank
It doesn't. Ish.
There's Dina.
Okay.
You- thank you, Sbu. I think that they should look in.
Thank you.
Yeah, I think this forms part of the restructuring of the workshop, I think. Might look into that to get the ideas early. The money will come.
Good afternoon, everyone. My name is Tato Tebe, and I am a second-year industrial engineering student. So there's a picture of the beautiful train, like Mr. Nanzelele said. So today, it's been such a pleasure to be in the company of such great minds which show how innovative industrial engineering is. So I'm grateful to be a part of this and learn also and receive positive criticism. So I did research, and I came across this topic, predictive maintenance on the rail car under frame, by myself. So according to the Gibela manuals or research, they've said that there's 2.3 million rail commuters, which is expected to double. And this can only mean that train stations will be very congested, and this will lead to a high demand of commuting by train. And other people generally prefer to take the train instead of the taxis because it's much cheaper for them. So that already tells you the trajectory of where your demand is going. And obviously, any other company would love to deliver a reliable product and that is safe, like the How Train was mentioned here, and that is comfortable and has convenience and the speed also, you know, when you're rushing. And I read that Gibela has a 19-year contract for maintenance, and it's supposedly preventive maintenance. So I chose this topic because I wanted to explore more on predictive maintenance that's smart. So we know that preventive has always been everybody's preference because it's the much safer option, but it also has its downside, like it's based on the usage and time of the train, which sometimes can be very inconvenient considering the downtime of the train, especially when you expect a lot of people to take the train, so meaning you're losing a lot of money. So this type of maintenance is much elevated than the predictive one, because here then you know that you have your planned downtime of which you can be able to make availability for the time that your train is supposed to be maintained or repaired. So like for instance, the service points all over our country have there's repair centers and then there's overhauls, of which there's been many overhauls, which kind of is a disadvantage, because then if you don't find a problem, that means you lost a lot of money. And it only means that also preventive has people waiting longer at the train stations, and other people just give up and can't wait any longer, so they will go to the taxis or elsewhere to spend money there. So the aim of the study is to develop that smart predictive maintenance system for the railcar underframe. Now, the most consumable components of the underframe is the brake pads and the wheels and the motor. So I did a comparative study here for the preventive maintenance and predictive with some stats from companies that have already implemented the predictive maintenance. So according to Deloitte, on average, the predictive maintenance increases productivity by 25% and reduces breakdowns by 70%, and it lowers maintenance costs by 25%. And for preventive maintenance, they say you have $1 in $3 is used for preventive maintenance, and that is wasted. So preventive might prevent the failures, but predictive limits the failures. So if you know that there's something that you have to prevent, then you know that it is a problem, because you always constantly have to prevent it from happening. But if you stand at a better chance of longer times to actually getting to that failure, it gives you a strategy already on how you're going to implement a system that's going to work best for you. So the predictive maintenance is based, it's data based, which is where we're headed as the world. A lot of people are already involved in data science, data capturing, and Internet of Things, and all of those. And preventive is mainly based on usage and time, like I said. And also, for this predictive maintenance, you are able to maximize production because, like I said, you have much better insight of your schedules. Like maybe, for instance, for predictive, you can be able to predict your maintenance plan for the next 5 years maybe, and with preventive, you can only see out to 3 years or 2. Also, this is a safe and efficient method of maintenance because it's very ideal and reliable, because you have months of data and you don't just rely on having to take in your train for overhaul or to assess if there needs to be an action for maintenance. So there's quite a number of technologies for this, because like I said, we're trying to find a smart predictive maintenance. So I came across a lot of them, like real-time data consumption, which is mainly sensors that are placed on the train to be able to monitor the train as it's on the track. And like you can use your service points around the country, integrate them to make them data collection centers, because I mean there was COVID, meaning there were not a lot of people taking the trains, and meaning a lot of trains were not functional, so making the depots also not functional, so there was a lot of money lost. So maybe if you can also integrate another working service there to make money for such instances where you can't predict where the country is going to go, then at least you can be able to make money that way. Also, there's also the Alstom train tracer that is used to capture the data. So that's already a system in place, and I know that you are working with Alstom as well, so that could be an advantage. And there's also vibration and wear analysis, like in instances where you know that, for instance, maybe the brake pads can have a catastrophic effect on some components on the underframe, then you are able to have better information on how that will turn out. So there's also advanced analytics, which is mainly used by Deloitte, yeah. And from that data, you are able to analyze it. So obviously in implementing this kind of system, you, like I mentioned Alstom, you already have somebody who's already implemented that technology. You have masters and PhD students who are here and have been presenting on certain types of technology. So you have insight. All you need to do is have experts that are already implementing that to gain some insight in you in helping you move forward. So in analyzing this data, you can use visualizations, you can have analysis process, and you are able to extract, analyze, have like a rule maybe in how you analyze your data, how you get to detect the failures. So like you have your parameters, you know that you're monitoring your parameters in the data that's been collected from your train being operational, your temperatures, because it gets really hot there on the wheels, your temperatures, your pressures and voltages. And then from there you are able to diagnose the data with the insight that you already have from all the research that's been done here, and hopefully will be funded to move. So you're able to deduct a simple rule to be able to diagnose a problem that you might have on your underframe. So now you get to a decision from analyzing that data and getting a diagnosis, whether you take corrective action, which means you design a schedule for your trains to come in for maintenance. Now you know for sure that they are going to be maintained. And then if it's a yes, then you can monitor the whole process and log in the data, because you can also use that data as it accumulates and it builds up a log of data, so that in future it becomes an immediate reaction to determine a fault or a future failure. And if you don't need to take action, then you just keep those records to define the norm of the process. So you always have a standard for what is the norm and what is the anomaly in that. But then obviously processes like this will have successes and unsuccessful results, but then you need both to be able to collect the data in making an accurate decision. Thank you.
Thank you. 2 hands up question. Dr. Danian, then Luvuyo.
Thank you so much for that great presentation. It's a very nice one. I just want to give this advice that, if I'm the one doing this work, instead of the word smart that you use in that title, I would rather go for intelligent. because not all smart systems are intelligent, but all intelligent systems are smart. And in the context of the work you are doing, you have already highlighted in this particular slide that the system will be able to carry out diagnostic function and prognostic function. So you'll be able to take decision and effect corrective action. So in that case, an element of intelligence, decision-making capability is already there. So I would rather go for intelligent system rather than smart. What you are doing is a bit advanced than just smart system. Thank you.
Thank you, Doctor. Thank you, Dr. Dan.
Hello. I think maybe my colleague here cautioned me a bit that these are undergrads, so I need to go a bit easy. So I missed so that you are doing undergrads. So yeah, I haven't had my afternoon coffee yet, so I apologize. So I think maybe Prof, one of the sponsorships that maybe with the restructuring of the GROWS, one of the sponsors for this type of project that you're doing, I would recommend Bongeka. I would not, I would say also and myself, but yeah, in the interest of not seeming like I'm marketing myself, I would say Bongeka, and then Bongeka, I work a lot with her. So because most of the things that you're talking about, I would say they're already in place, if I can put it like that. So when you talk about underframe, for example, so I'm not asking a question actually, I'm sort of maybe providing some guidance. When you talk about underframe, on the underframe, I don't want to say statistically speaking, mathematically speaking, 70% of your train equipments are on the underframe. So if you talk about underframe, that's a lot of equipments because you're talking about 70% of the train just sits on the underframe. So if you can maybe narrow it down, and if I can guide you in that one, there are some mechanical parts on the underframe, things like your steel components, metal components, bogies that do not require maintenance in the long term. So they are built to last, I don't want to say forever because they're not made out of gold. So you just target the ones that are already linked to the electronic signaling of the train. So we do have those components that periodically send data to the train. And when you talk about train tracer, then train tracer sends that massive data. It's not even big, it's massive, because some of them ping the train every 3 seconds. So in a day, you're looking at a lot of data. So I think maybe if maybe you can link with Bongega or myself, then we can maybe guide you in terms of zooming in as opposed to underframe, because then underframe, yeah, maybe they might give you one of those honorary doctorates to say your piece is so big that it deserves a doctorate, because yeah. So I think, yeah, I think start from there, limit it to the ones that are already sending electronic signals to the train, and then that data, I don't know, Messi allowing, we can be able to maybe give you some access to it, as maybe if we implement the sponsorship thing with the director that's coming tomorrow.
Thank you, Titi. We forgot the PC. Thank you a lot for that closing comment, Luvuyo. So the exercise was not in vain. We are about to reach the end of our program, and right at the end we have our 2 postdoctoral fellows. One is online. I think he'll be ready after this presentation. But we now welcome on stage the gentleman that's been guiding this discourse a lot. So it's our time to engage him. Dr. Danian, The title of his talk is Design and Simulation of a Novel Digital Technology for Rail Car Bogie Assembly.
Yeah, thank you so much for this privilege given to me to make this presentation. It's a work in progress, and as much as possible, I will be happy if there are constructive inputs that can assist us, to get to where we are going. So this is the presentation outline. I have the introduction, background, problem statements, the aim and objective, methodology, results, conclusion, future work, significance, and relevance to the study. So now to the introduction. The rail car bogie comprises of so many interrelated components. And then for the bogie to meet its service and functional requirements, there is a need for the components to be properly assembled in line with the standards and specifications. So there are so many challenges that characterize the assembly process, ranging from assembly error, low productivity, lack of operational efficiency, poor compartments of the bogie components, increase in manufacturing lead time, and then so many other problems. So in a bid to tackle this problem, we propose the design of an intelligent system that can enhance the assembly operations of the rail car bogie. So just like I've said, the assembly operation is a fairly intensive process. And then some of the challenges include assembly error, time and cost constraints, sometimes poor quality of the assembled bogie components, which can lead to reverse engineering, and in the process, substantial cost will be incurred, and then poor handling of a complex assembly operation, which is sometimes a challenge for organizations that still rely on manual or semi-automated process of assembly. So that is why we are proposing a fully automated system for the assembly of the rail car bogie. So the aim is to design and simulate a novel digital technology for rail car bogie assembly. So some of the objectives include the literature review, the feasibility study, the design requirements, and then assembly, then the process selection. We also carry out the finite element analysis in the Abacus environment and the virtual simulation using the SimLab software. So these are some of the literature review that have been consulted. So if you pay a close look at number 3 to number 5, you discover that even within our research group, we have done some, background work on flexible manufacturing system that can, be used for assembly operation, a dual arm robot that can be used for assembly operations in the rail car industry. And Mr. Skosana also carried out an empirical framework for developing and evaluating a virtual assembly training system. So although this work, most especially 3 and 4, are still limited to design, so we hope that the work will transit to the prototyping stage. So one of the features of this work is that it seeks to integrate the virtual reality technology into the design landscape of the rail car bogie system. So for the methodology, these are some of the components that are to be assembled together: the bogie frame, which is the chassis, the link arm, the adapter assembly, the bolster, the braking system, as well as the transmission system. So the flow diagram of the assembly process is depicted in figure 1, whereby the card and the specifications, are translated to the development and the assembly process of the rail car. So I will not dwell much on that. I will proceed to the next slide, which is the layout of the assembly floor. So if you look at the diagram on the right, so we are using a continuous synchronized assembly floor, whereby we have the 2 types of robots. The first one is the pick and place robot that will pick the component to be assembled from the component box and place it on the conveyor system. So it will pick it from the workstation 1, and the conveyor will move it to the workstation 2, whereby the assembly of the standard and non-standard parts will be carried out. So particularly for this work, the pick and place robot is embedded with a selector that is able to carry out the orientation of those components in real time. So what I mean is that according to the control system, the control is programmed such a way that the sequence of the operation is synchronized. So if the orientation, if the component is not oriented, the pick and place robot will reject it. So the essence of that is to avoid assembly error, so that we can be sure that any products coming out of this will be fully aligned and compacted. So I will proceed to the next slide. We carry out the Proteus diagram of the control circuitry. The robot A stepper, which we have at the left side, represents the pick and place robot. And under it is the driver that drives it. That's under it. So to the right side, we have the robot B stepper, which depicts the grinding robot. Because for those non-standard parts, majority of the machining operation, aside the finishing operation carried out, is mostly grinding operation. So the second robot can perform manufacturing, machining operation, most especially the grinding operation. So and behind it, below it, we have the the driver for that motor. So if you look at D1 and D2, up there, it represents the light emitting diode. And the function of that is that as soon as robot 1 picks those components, it will trigger D1. And the essence of that is that there is an indicator that points to the fact that a component that is ready to be assembled has been picked, placed on the robot. So, and in between it is a sensor that will alert the second robot, to be prepared to pick the components. So the same thing, D2, we trigger as soon as robot B is able to pick the component from the conveyor. So in between them, just like I've said, we have the trans receiver sensor. Then if you look at between robot A and the driver, we have a sensor there too, which is the optical sensor. And the essence of that optical sensor is that whenever the carrying capacity or the limit capacity of the conveyor belt is reached, so it will automatically turn off the feeding mechanism. So then we have another robot in between the driver of robot B and the robot itself. So as soon as the queue disappears on the conveyor system, it triggers the feeding mechanism again so that the material loading can commence. So at the center is the Atmega microcontroller with the codes which represent the sequence of the feeding operation to be carried out. For instance, now, if you are dealing with the frame now, the components that will go along, that will be assembled together with the frame, can be programmed into the Atmega microcontroller at the center. So then other components, including the CCD camera to capture the images in real time in form of video or in form of images. We have the arrays of sensor, the transceiver, the optimal sensor, and so on and so forth. We have the part components, whereby the components to be assembled are specified according to their part family. The LED sensor, I think I've talked about others. So the simulation was carried out in the virtual assembly process, was carried out in the virtual assembly environment, just to have information about the assembly process in an artificial environment. So the 3D model was imported into the SimLab software, and then this is the result that was obtained from a fully immersive virtual environment of the assembly robot that performs the grinding operation. So particularly the robot, the payload for the robot is designed to carry a maximum load of 400 kg. And if we convert that to Newton, we have approximately about 4,000 Newton. So this aspect of this work investigates how the assembled components, you know, how the assembled component, the quality of the assembled component in terms of the applied force. So we investigated the gripping force, and just like I've said, the gripping force is limited to maximum force of 4,000 newtons. So we investigate the effect of that gripping force on some of these components to be assembled. So we pick on the frame, and we discover that the effect of the gripping force, you know, after we have simulated in the abacus environment, we find out that the stress distribution ranges from a minimum value of 16 megapascal to a maximum value of 99 megapascal. And if we compare this to the yield strength of the material, cast alloy steel, from which this frame is made, we discover that it is significantly lower than the yield strength of the material. And the import of that is that the gripping force of that robot is not likely to cause any disalignment or any displacement of the frame. And if we look at the result obtained on the right-hand side, it lends more credence to that result obtained in the sense that the displacement is negligible in the tune of about 1.529 times 0.0005, so it's negligible. So that is in the X direction. The same thing, similar result was obtained in the Y direction. The displacement was maximum. So it means that the effect of the gripping force of the robots on those components to be assembled is not consequential. So it's still within the permissible limit. So we also study the overall resultant effects of the force as well as the displacement. The same thing, we find out that is significantly lower than the yield strength and the tensile strength of the material, which points to the fact that, you know, the robot can be used to assemble these components, you know, and we are able to obtain a high quality product, assembled product under this condition. So we look at the strain that can be caused as a result of the impressed load, and if you look at it, you discover that the strain is approximately 0. So which also lend credence to the result obtained that our design is still within the safe limit. So the novelty of this work lies in the fact that the design and simulation of the buggy with the aid of the virtual reality technology and the abacus software has not been sufficiently highlighted by the existing literature. So this is one of the focal points of this study with the aim, you know, to establish some of the design requirements that is needed even for this digital technology, proposed digital technology. So it is expected that the fully automated digital technology for this assembly of rail car will be able to carry out repeatability with boast of high productivity, flexibility, reduction in residual stress as the abacus result has given us, time and cost effectiveness, and reduction in reverse logistics. So the business case is that the technology can replace manual or semi-automated method of assembly operation. So the personnel that are working manually may be trained, you know, with their skills upgraded for deployment into another department. It does not necessarily translate into retrenchment when a fully automated system, you know, is used for this assembly process. Then the implementation of this technology will break even. It is, you know, estimated that it will break even after 18 months. So to the conclusion now, the simulation carried out indicated that the system has the capacity to perform intelligent coordination of the buggy assembly process with significant improvement in the assembly precision, quality cycle time, and cycle time during the assembly process. So it provided an insight into the assembly process automation and intelligent assembly of rail car sub-assembly system. So based on this finding, the redesign of the work layouts and then the work environment is recommended, most especially for organizations with manual assembly layouts. Furthermore, effective process design of the welding processes can also be carried out. Future work can consider the development of the intelligent system and performance evaluation. So we have the significance of the study, which I've highlighted, and the relevance to the industry. So that has brought me to the end of the presentation. Thank you so much.
Thank you so much, Dr. Daniel. We have the first question from Prof. And a note, Alice Luvuyo, number 3. We'll take the first 3 hands as a round.
Thank you very much, Dr. Dan, for the work that has been put in to align to this 4IR. I just want to understand from a financial perspective, I think it's important to speak to those elements. Earlier on we heard that we need to reduce our time to 12 months for the project to be regarded as viable. So already this project is thrown out of the window as it stands. What is it that you will do to make sure that less than 12 months, the value is derived? And I also want to, we've always been playing this Plan A game where we speak about sustainability, future viability, and I just want to get a sense of, from what you have done here, what are those sustainability aspects, whether it's economic, it's environmental, that this work addresses? That would be my questions, the 2. Thank you.
Sorry, Alice, they gave it to me. So, Doctor, I have a few questions with regards to this, because I think more than anything, the manufacturing of a component like a bogie, personally, I know that if you try to make any investment in that field, you need a lot of bogies so that it can pay itself back, of which in the African market, not even in South Africa, in the African market, we do not have the economies of scale to make significant investments in things like your bogie manufacturing. So I wanted to ask, the system that you're proposing, how much does it cost, and what is the buyback in the number of bogies? To say, okay, it will cost you 6 million or 60 million to implement, and after manufacturing X number of bogies, that is what I base my, I think you said 18 months as a break-even point. So I want to know that 18 months, how many in terms of bogies? How I've used this much to buy it, and I've produced this number of bogies to get to that 18 months that I am referring to. And then the question now that I want to ask is, if as Gibela we say we are interested in this system, or our sister company that manufactures the bogies, I'm interested in this system, I want to implement it, what is the Tact of One Robot? And how many robots would you need to produce 864 bogies a year? So based on, I'm sure with your break-even point values and everything, you would have some of this information. And then, and then on your problem statement, if you can go to the slide with the problem statement, I see you spoke about assembly areas, poor quality, low compactness, and poor handling. Do you have the numbers of those to say assembly areas for people who manufacture, for people who manufacture bogies, whether manual or advanced? This is the number of assembly areas they have, and this is how much it's costing the organization, as well as poor quality. Out of 1,000 bogies that are manufactured, we have 7 that need to be scrapped, and things like that, because I think those speak to, is the research relevant? Because you spoke about relevance of industry as well. So if we have those figures and numbers and the values, then we can say, yes, it is relevant, and then I think for me personally, it would make your 18 months break-even point more believable. And from where I'm sitting. 18 months is, yeah, I don't want to say pie in the sky, but yeah. But let's hear the answers. I could be wrong. Thank you.
Okay, let's take Alice's question, then give Dr. Danyan an opportunity to respond.
Dr. Dan, I did not get to understand the types of robots that you'll be using in your system, as well as the degrees of freedom that are actually on your robots. Can you clarify?
Thank you. Doc, you may respond.
Okay, thank you so much. So let me start with the first question from Prof, which speaks to the financial perspective. And just like I've mentioned earlier, it's a work in progress, and the financial aspect of it, the feasibility study in terms of the economic implications is still under study. But we envisage from our previous research that have been carried out on it, because we have been on this work now for quite a number of years. And then, by the grace of God, we have made some publications on the assembly of Enrica Bogi. So drawing inference from some of our work, it is envisaged that within 18 months, the venture should break even. But just like Prof have said, if we are to reduce that break-even time to 12 months, then it means that we need to put in all other aspects into consideration. So then, to the sustainability aspects, if we look at sustainability from material perspective, the energy consumption, the environmental friendliness, and the cost effectiveness. So we find out that research has proven beyond doubt that fully automated systems are more sustainable than manual and semi-automated system. Because one of those reasons is that for fully automated system, mechanisms are put in place to ensure that the system does not consume energy more than the one that is required. And then another thing is that the system will also ensure that there are no scrap materials that can, bring about wastage of materials. So if we discuss the sustainability aspect of this work, I believe that it boasts of material, energy, environmental friendliness, and cost effectiveness. Of course, we link energy to the environmental friendliness, because the lower the energy consumed, the more friendly the process is, and vice versa. So though more work will still be carried out on that. So I will go to the second one now. So it still speaks to the first question that Prof asked about the cost. So as soon as we are done with the feasibility reports on the economic aspect of it, we will make it available even to the research share. So that is about the cost feasibility. So, but the estimated buggy that can be produced per month, according to our previous research, was estimated at about 1,020. So, though I don't have the, what's it called here, but I can refer you to some of the papers that we have published that speaks to this data. So then, to the problem statement in terms of the assembly error, the time constraints, the poor quality. So this problem statement, because we are not considering a particular case study, so we drew a general inference from some of those challenges that characterize the manual and the semi-automated system. And some of them include assembly error, which sometimes lead to reverse logistic, time and cost constraints. Because of course we cannot compare the way a fully automated system will work to the way a semi-automated or a manual system will work. And there's a link between time and productivity. There's a link between cost and productivity. So, so I will put it at that we have not considered any particular case study. If we have considered a particular case study, then it will be easy for us to come up with a statistic that speaks to this. Then in terms of the last question, just like I've said, we consider two types of robots. The first one is the robot that has the capability to pick and place on the conveyor system. And the second one type of robot is the robot that can carry out machining operations. So the machining operation majorly speaks to the grinding operation, though there are some other light machining operations that can be carried out. So this one is also, what is it called now? If you look at the slide we have here, point number 4 says design and simulation of a arm robot for manufacturing operation. So these are some of the work. It's a continuation of this work. And particularly for this dual arm robot, you know, the degree of freedom is a 24 axis robot. So it's a robot with 24 degrees of freedom. So we are building on some of this work that have been done within the research unit. So for the two robots we speak about, they have capability for 24 DOF. I'm not sure if I've been able to at least. Thank you so much.
Sorry, take the last round of hands. Going once, Ms. Medise. Thanks.
Dr. Daniel, thank you for the presentation. But now I think it's a comment rather than a question. I think one of the things, Prof, earlier on when the panelists were talking, I think now we need to look probably into a direction because, for an example now, the comment that Luvuyo made and looking at Dr. Danyan's study, for us having a rail company that we even have a partnership with, and then now our studies not being aligned to that, and we getting questions like that from Luvuyo. It's you know, because I think we've got a reference point over and above maybe the academic work that we do. So maybe my suggestion is that because Luvuyo was saying 18 months in terms of this, because practically, I think maybe from his side it was not as practical as, you know, but maybe basically what I'm saying is that maybe going forward with these planning sessions and all that, and probably again, Luvuyo, you give us that access that I can just give you a call and say, listen, I've done a paper, are you able just to look at it? So that I don't come and present and you are the person who's doing the application of this specific work, and then now you say, you know, if we had another industry partners here, it was going to be a little bit to say we've got partnership, but now we are not really communicating, you see. So basically I think maybe going forward with I think this is a lesson learned, even probably even us when we write papers going forward, we will definitely consider if we have to speak to the industry people and all that. So I don't know if I'm actually making sense on this one.
Oh,
All right. No,
Very clear.
thank you very
Thank you.
much.
Thank you. ma'am.
Thank you very much.
Thank you, Mamudis. Where do we go first? Mr. Najara? We'll come back to you. Let's go to Luvuy. Maybe he wants to respond.
Yes, Doc. So I think I have a question actually, because I think the point that she is making in terms of industry partners and everything, it is part of the restructuring we're discussing with Prof, where Messi did say that there will be a academic sponsor, and then there will be an industrial sponsor that speaks to practicability of, this paper. It might not necessarily be me. There are many smarter people than me in Gibela. So I think they would be best suited because they're much smarter than me. But I want to ask Doc a question, because your presentation was very specific on break-even point is 18 months. I think that's why I'm sort of emphasizing, because the break-even point is specified at 18 months. However, when you ask the questions on cost and how much does it cost, you're still saying that because it's a work in progress, you do not have the numbers yet. And I don't know, according to my limited knowledge, break-even point is when the revenue starts being equal to the total cost. So I've bought it for 5 million and I've made revenue of 5 million. I could be wrong. And that's when we say we've hit our BEP. So I think that's what bothered me, is like 18 months, but we don't know how much it costs. So I'm still questioning what was the basis of 18 months for the break-even point specifically now. Thank you.
All right. You want to answer now or at dinner?
Yeah,
It's
thank you so much for that question. Yeah, except maybe I ran out of the right choice of words. I thought that I mentioned may break even, maybe a future or a conditional statement that it may break even by 18 months. So, and what informed that decision is that, just like I've said, we have done some work on this, and though we cannot practically base the conclusion on the previous work that we have done because the systems are different. So that's why I'm saying by the time we finish the cost implication, the cost aspect of this work, and then we'll be able to be very specific about the break-even point. But we are emphasizing that it will break even by 18 months. And the work is work in progress. So we are still transiting now to the detailed design and the calculations. And after that, we get to the prototyping stage. So I believe that by the time we get to the prototyping stage, all the cost implications and the feasibility aspect of it must have been ready. So by that time, if opportunity presents itself like this for this type of occasion, we'll be able to speak to those figures and statistics. Thank you so much.
Thank you, Dr. Adenuga. Dr. Daniel. Thanks a lot. We have an online presentation or mode by Dr. Adenuga, and it's titled Energy Efficiency and Carbon Emission Baseline Development in Future Transport Industries, an Approach Towards Low Carbon Product. Dr. Adenuga.
That's a Kano.
Thank you, sir. You are audible.
Can you see my screen?
You may begin. Thank you.
Mr. Sekano, good afternoon.
Dr. Adenuga, how are you?
Yes, can you hear me?
Clearly.
Yeah, my screen. Can you see my screen?
Your screen is very visible, Dr. Denuka. You may continue.
Okay, thank you. Good afternoon. The screen is nearly now appearing, but okay. I think that's the title of my presentation. Can you please adjust the mic? I can hear echo from my end here. Okay, the name is Olukorede Tijani Adenuga. Hope my voice is being heard clearly.
You are clear, Dr. Adenuga.
Okay, thank you. Is my screen showing? The title is Energy Efficiency and Carbon Emission Development. This is an product. Can I continue? We have seen and it's been adopted in the South African setting that energy efficiency is seen as first fuel and a way of life. We started this conception in 2018 when we have a funding agreement with Gibela, and from literatures regarding energy efficiency, with the paper published, it allows industry and commercial consumers to make informed decisions based on the knowledge of the electricity usage and cost with regard to emission. And we have seen that energy efficiency market entails building capacity for industry in terms of initiative for a culture towards resource efficiency. Energy management research have grown considerably, and that is from the work of May et al. In the last decade with the application in different production fields. And the initiatives we have developed from the work published in 2020 is a key factor towards climate change mitigation with variable renewable technologies. The problem we have identified so far is that 95% of generated energy are gotten from coal in a South African setting, and 85% of it goes into emission. And we realized that from the data we got from Gibela in 2018, prior to ramping up their production, 26.6% goes into lighting, ventilation, and other auxiliaries. But bulk of it goes into lighting and ventilation. And it is from that data we realized that 52% of this energy only goes into production, because that is prior to ramping up production. And we believe by now they will have ramped up production that will have outweighed the percentage, probably drop the percentage of the lighting when compared. And when we go by that 62%, it is emphasized that 65% carbon dioxide emission will be emitted into the environment from the generating station, not from Gibela angle. So we must have this at the back of our mind. And we have realized that most researches or research does not apply in practice to energy efficiency. And the use of IoT energy management systems, which involve real data, are not being really ventured into in terms of research. We then came up with those findings from the problem to develop energy efficiency device, which is a solution that have cloud hosting with cell network and modem to interface with the equipment and the data that is gotten from the industry. This device has capability of taking 120 sensing energy device at a go. And it's been tested and I think it's being used in our center at Artfeed. This is the sample of the energy, active energy usage consumption that is predicted when you are using such an amount. We take a case study of electric motors, which is a higher corporate in energy consumption. And with the energy efficiency initiatives, we can see that when you bring about the use of variable frequency drive and set it at 50% for 20% time, or at 80% for 50% time, or at 100% for 30% time, you realize that from the total energy that we'll have consumed at 396,000 watts, we will save, we will use just 49,000 if we set our variable frequency drive at 50% for 20% time, or 203,000 when we set it at 80% to 50% time, or 396 exact one when we set it for 100% at 30% time. And when we apply, come up with this affinity model, we realize that hourly cost savings can help the user of this type of electric motor to save about 12,000 rand in terms of cost. And this is the methodology we are talking about, the affinity model, where you have to put the percentage of the varying the frequency drive into use to help reduce energy consumption for electric motor. And these are some of the analytical data that was gotten from predicted and residuals from those study. Then we bring in students who have presented the colloquium this morning. A PhD student who is working around hybrid ARIMA LSTM. In this case, we are using a statistical model and a machine learning model based on the data we got. And the data are time series data, and we are able to use 20% of that data to train 80% and do the prediction to know. And this is the architecture of the LSTM, which work based on getting a residual from the series, because ARIMA takes care of linear data, while LSTM handle the nonlinear data. So we have to bring the two together to be able to do our prediction perfectly. And that is the result from our PhD student that is working around energy efficiency and carbon emission. And we apply this factor, which is the carbon emission factor set in South Africa, which is 7.055 multiplied by 10 raised to power minus 4. So for every energy that is consumed, this factor, when applied, gives you the carbon emitted. And for coal energy content, we use a baseline of 25.52 megajoule per kilogram of coal used. And putting this into our Leontief output mathematical model. So we determine the CO2 savings that we can envisage. I won't want to bother you about the mathematical notation much, but what I want to bring out in this slide is that, take Gibela for example. Let's assume we deploy our energy efficiency device and we put it on various machines that is used to produce the ray car bodies. To produce 1 unit of that ray car bodies, we will need an energy which require a certain amount of energy intensity and of CO2 savings. And let's assume we connect it to about 120 machines. Then we can come up with the CO2 that is emitted for every energy that is consumed by this machine. And that is the thinking around this. And this is for the data we have used, we got this data from National Cleaner Production Commission, who is a company that focus mainly around energy conservation and energy savings and energy efficiency. And we are able to use a car body to carry out our study, and we realize that we do 29% savings from those data. And this is what I talk when we talk about when a data is linear and non-linear. So when you get a data, the first one is showing us the blue is the energy, while the one in orange is the emission by carbon, which is exact equivalent but in different percentages. And when you have such data, you have to trend the data and see that the data is not straight line. So it makes it non-linear, and you put 6 in and to try and smooth those data, and the residual you got, you put it into the LSTM, and that will help you be able to use the 20% of that data to train 80% of the remaining. So, and another solution we have come up with in the course of the research in energy is to now bring a solution around renewable energies, the use of renewable energies, which was based on the use of solar PV array, fuel cell, and supercapacitors. And this was done on MATLAB, simulated by one of the students who is currently doing his master's with the electrical engineering department. And it was an intern with us at Gibela. And we look at our grid simulated load to be 160 kilowatts, then the fuel stock at 53 kilowatts, the solar at 85, and we look at the value combined fuel cell grid, solar grid, and the total consumption that we can get. And this is to take care of a part towards eliminating the use of coal. So for a company that has the capability to afford solar and the use of either solar or the use of fuel cell, we can run this simulation for them to help them help our environment, also save some money for themselves in terms of energy. And this is the result of the statistical models, and this is the result of the prediction, which shows that the actual train it's at 59 and the prediction test at 58.4, and the predicted days are for 5 years, which shows in blue. And so far so good. In the course of my career advancement a research fellowship. I've been able to publish 13 journals, 4 submitted by my students, and some of the 13s are also publication from my students, 1 under preparation. I've published about 10 conference papers. I've participated in 7 conferences, both local and international conferences. And for workshop like the one we are holding now, this one is the 5th series. I've participated in 5. So far, in the last 4 years, I've graduated 4 masters, and 5 masters is already undergoing an assessment. So far, under my supervision, I have 20 masters under my supervision and 2 doctoral students under my supervision. And confidently, they are progressing well, and most of them are around within this workshop. Participation in the research and innovation projects, I've done 9 and 1 chapter in a book. So far, so good. What are we trying to project by energy efficiency is to show the interrelationship of possibility which resulted in 29% improvement in total energy intensity on vehicle body parts based on the methodology we have adopted, and 7.22% in cumulating energy savings and 16.25% in energy efficiency. These initiatives provide a prediction model for energy cost against usage. And for companies that are interested, probably your company may have so much bulk to pay an energy bill. So this technology or the devices is using Wi-Fi, Ethernet, GPRS 3G, and Zigbee Pro. And the scope could serve as a fundamental guideline for future studies in future transport manufacturing, which is our basis for going into research. And thank you. So I think I'm done.
Thank you so much, Dr. Adenuga online. Do we have questions, ladies and gentlemen, for Dr. Adenuga, or some comment? Dr. Mvunzi.
I want to start by thanking Dr. Adenuga for the great work. Mine is not a question, it's just maybe a contribution on what the future may be. I mean, in our country, it's a reality that we are faced with the problem of load shedding. Is it possible that, I mean, as an expert, as far as the issue of energy is concerned, that we may maybe use such type of expertise maybe to develop some energy storage systems which can kind of buffer us, let's say in the event that there is load shedding, since we are able to calculate, let's say for example, that for this machine to work effectively for 4 hours, we need this kind of energy. Can we not use that expert to sort of come up with energy storage system that can buffer in the event of load shedding? Because it's a reality, I mean, it's affecting productivity. So yeah,
Thank
it's
you,
just a contribution. Thank you.
That was the only hand. Dr. Adenuga, are you responding?
You hear me? The program director.
Please proceed.
Okay. So far, so good. We won't have option because we have been experiencing load shedding in South Africa at present, and the only option out. That was why we came up with the simulated result for use of solar. And you can start from getting a 1 kilowatt solar capacity, just 2 solar panels, and we have an in-house SMEs that have attended training in that regard. In the name of Tubelani, is running his master's presently, and is also an SME in that regard. So we deploy such for interested member. So, and that is that.
Thank you very much, Dr. Adenuga, for the presentation. Ladies and gentlemen, according to the program, we promised to set you free at 17:20. I don't think we are far off the mark, so if I do campaign for presidency in 2024, consider. The offline conversations that we've been promising each other the whole day are going to happen now. Is the session for them. And before we do that, we will join the gentlemen that have been capturing us the whole day. They will show us where to capture a group picture. Thank you very much for your engagement and patience.